Hi everybody. So today I'm looking at lesson 7, radical functions and radical exponents. Thankfully, now we've ended lesson 6, lessons 5 and 6. Those were pretty challenging, but these ones are going to be kind of okay. So I hope that the next test that we have, all of you are going to do really, really well, better than what you did on lesson 2. So here we are going to start with roots, and then radicals, and then rational exponents. So please follow me as we go through this. And I think that I'm going to make another video. I'm going to do another video after this one also. This would pretty much be for an hour. 1 hour. All right, so first of all, let's talk about square roots. So for square roots, many of us are familiar with square roots. All right, so if you look at this, we have the square root of a. So the square root of a equals b. If we have that, then what does this mean? It means that I'm going to go to the whiteboard and then we'll talk about this a little bit. This means you could have, so square root of a equals b. This means that b times b equals a, like that. Okay, so b times b equals a. In other words, b squared equals a. So we can have b times b equals a again. All right, now for square root of a, we could always write square root of a as this: a to the power 1/2. So a to the power 1/2 equals the square root of a. Okay, and this we could also write this as a to the power 0.5. So this is an exponent, that is an exponent, because 0.5 is the same as 1/2, right? So it's pretty much the same thing. So all we are doing is that we are trying to, look at the multiple ways we could write the square root of a number. And here we are representing that with the number with an a. All right, so if that is fine, we're going to keep going. Now on your calculator, on the 83 or 84 calculator, if you look at where you have the x squared, so if you hit second and then you hit the x squared, you have the square root button. Okay, so you should do that. I think the 83, what I'm looking at right now is the 84. So I think the 83 is pretty much the same thing. So look at that and then you can find that for the square root. You could find that for the square root. All right, let's keep going. Now, when we go back to what we were looking at, so from here, we have the square root of 25. The square root of 25, and this is written in a radical notation. Radical notation is like that, okay? And then a rational exponent notation is that a to the power 1/2. That is a rational exponent notation. So here we see that it's written in a rational notation form. All right, the square root of 25, which equals 5, because 5 squared equals 25. I already explained that with a and b. All right, now look at b. When we have a square root of a number, let's do square root of a. Now, if a square root of a, remember, equals b, like that, right? Then let's say that, think about it this way. let's say that I want to square both sides of the equation. So I put this in parentheses and then square that also. So what do I have? The square root of a squared equals b squared. That's what I have. Now, remember that from what we just did on the whiteboard, we know that square root of a equals b, then b squared equals what? A, right? The square root of a, the square root of 4 equals 2. Square root of 4 equals 2. Then 2 squared equals what? 4, right? So our a is 4, our b is 2. So if that is the case, then I know that if I square both sides, that is if I square this part, oops, and then I square that part, b squared from here gives me a, right? B squared from there gives me a. So if I think about it that way, then because I've got a square root and then a squared, then I could say that this will cancel that. So the square root is going to be cancelled by the squared, which gives me a. A equals b squared. Then I'm back to this guy here. B squared equals a, or a equals b squared. So anytime you square a square root, it cancels out. The square cancels the square root. So you have the number left. And that is what we are seeing for this problem B. We have a square root of 144 squared. So the square root is undone by the square. Okay? So they pretty much undo each other and you get a number. All right? Okay. Now let's go to the nth root. The nth root. Let's go to the nth root. So if you have an nth root, like what we have here, a, the square root of what? N. Remember, this is not n times square root of a. No, the n is small and it's close to the root sign. So we say the nth root of a. N can be 3, 4, 5, 6 upwards. Okay? It should, the first thing is that n should be what? Greater than 0. But we know that when we have a square root, our n is 2, but we don't write the 2, right? We don't write the 2. And then if you put 1 there, it just doesn't make sense because you have 1 over 1, so that doesn't make sense. So after 2, you go to 3, 4, that you have to write them there. So this, a third root or a cube root, that's how we say it, a cube root, right? A fourth root, if it's 4, it keeps going like that. So by convention, we write square root of a as that we already know that, so I'm going to keep going. Now what about the fourth root of 256? The fourth root of 256, what does that give you? The fourth root of 256. So when you have the fourth root of 256, let me write that down. So I have fourth root 256. It means that I'm looking for a number that would multiply itself how many times? 4 times to give me 256. That's what I'm looking for. Remember that you could write this as, okay, you could write this from our formula, nth root of a equals a to the power 1 over n. So the fourth root of the fourth root of the the fourth root of 256 is going to be 256 to the power 1/4, like that. So again, when you have this, you always have to apply this kind of like formula, okay, for you to understand how to work with these. Now, when you go to the calculator, the good news is that you could enter it as that. Okay, this sign will give you the exponent. So 256, that's 1/4, like that. 256, and then that sign, the exponent 1/4, like that. Okay, so that should give you a 4. Now, let's look at the next one. So if you put that in a calculator, you get 4, which means that if I have 4 times 4 times 4 times 4, this should give me 256. Okay, so the fourth root of 256 is 4. Now, what about B? What about B? Where we have the seventh root of negative 2187. Remember, we could write that as negative 2187 to the power 7. You might say, negative number, how is that going to work out? It's going to work out because we have an odd number exponent, an odd exponent. Okay, an odd exponent. Remember that if you have, let's say, I'm just using this as an example, if you have negative 3 times negative 3, negative times negative gives what? Positive 9. Times negative 3, what does that give me? Negative 27. So you see it? So negative 3 times negative 3 times negative 3 will give you a negative number, negative 27. So just because you saw a negative does not mean that it's not going to be a real number. When it's a negative, it's not going to be a real number. The exponent, I mean not the exponent, but the root is an even root, an even number root, not the exponent, the even number root. Like this guy here, we have that 1/7. Because this is an odd number root, you know that you're going to get an answer. Just like what I did with the negative 27. Negative 3 times negative 3 times negative 3 equals negative 27. So if I do this, negative 27, and then I do a cube root of negative 27, it's equal to what? Negative 3. Negative 3. Which means that negative 3 times negative 3 times negative 3 gives me negative 27. Okay? So that's how you work with these. You work with these. Now, if you look at D, you would see that we've got a positive root. We've got a positive root. So that is not a real number. But if it were to be a negative root, then you know you're going to get a number. Now, what about C? Now, if you look at C, the negative is not under the root sign. The negative is not under the root sign. So the negative is kind of outside. So you solve this and then you attach the negative to it. What I mean is that you have negative cube root of what? 15. Okay? This someone can even put a parenthesis on it. So you solve whatever is in the parenthesis and then you add the negative. This is not the same as when you have the negative under the root sign. Remember that. Okay? It's the same thing. All right. All right. Now let's look at rational exponents. So assume A is a positive real number and PQ are integers and Q is greater than 0. So when you have something like that, you are going to have A to the power P over Q, like that. Now this is the clue. Always, even though this is an exponent, okay, the denominator the denominator is always going to be the root. The denominator is always going to be the root. Okay? Always remember that the denominator is always going to be the root. So this is going to give us the cube root, okay, of a times what? P. Or you could bring the p under the root sign. That's what it gives you. So always, 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 the denominator is going to give you the root. So if you look at a, the fourth root of 81 cube, the fourth root of 81 cube. All right, just give me a moment. I'll be right back. Continue. Just give me about a minute. All right, I'm back. So again, the denominator is always going to be the root. So if you look at a, we have the fourth root of 81 all to the power 3, right? So we know that writing this out, the fourth root, the 4, is going to be the denominator of the exponents. We have 81 to the power 3/4, like that. Okay, that's what we have. All right. Now, what about B? So again, if you look at how we dealt with this in this problem, we have the fourth root of 81 to the power 3. So what is the fourth root of 81? You put that in a calculator. I already showed you how to do that. 81, okay, 81, like that, and then to the power quarter. Or after this, you know that you have to what? Put a cube there, okay, a third power there. Or you just decide to do it just straightforward like that. 3/4. Okay, it's going to give you the same answer. It's going to give you the same answer. Now, if you look at B, and then what about C? What about C? If you look at C, with C we have 1 over 32. Because we know that the root is 5, that is going to be the denominator. So 2/5 on top as the exponent, right? So you put that in the calculator. You could solve this, and then 1 divided by whatever you get. 1 divided by whatever you get. Okay? All right. So the fifth root of 32, and then you square whatever you get. Okay? And then you 1 divided by that. So you could see that we had a quarter here. All right. So square root of 49 is what? 7. What about square root of negative 49? That is going to be a problem. Why? Because it's even. It's an even root, square root, because it is that. So if you do negative 7 times negative 7, it gives you a positive. So that's the problem. You're not going to get that. Okay. So you have to uh, remember that if you have an even exponent, and if you have an even root, then you cannot get a real number for a negative number. Yep. But if it's an odd root, then you could work out something. If it's an odd root, then you could work out something. So It is something worth remembering. All right, so let's keep going. Again, if you look at this here, you've got a cube root of -8, a cube root of -8, cube root of -8. Because this is a cube root, we know we can get somewhere. Why? Because we've got a negative root. We've got an odd root, sorry, and then a negative number. So we know that this is going to give us negative what? 2. Why? Why -2? Because -2 times -2, negative is positive, +4 times -2 is -8. Okay, that's how you do it. So these are not difficult. All you have to remember is that it just comes with practice. Watch the videos. Okay, make sure you're watching the videos, and I think they're going to help you solve these. So this is a media lesson, so I'm going to skip because it's there, it's on there, so you could watch that. Now the U try here, we know we are getting a 6. Okay, now what about this 16? 6. Okay, before that, let's go to this one. So we have a cube root. Again, it's an odd root of a negative number, so we know that this is going to give us -4. Why? Because -4 times -4 is +16, times -4 is -64. Right? So this is negative that. Now what about this? 16 3/2. Now you know that the root is the denominator, so you could do that. Square root of 16 cube, right? Or you could just put this in a calculator by doing 16 3/2. Okay, 16 3/2, like that. So what we have, the square root of 16 is 4. So we have 4 cubed, which is what? 64. So that's how you work out these kind of problems. Okay, that's how you work them out. All right. I hope that this is helping. Okay, practice, practice, practice. That's the only way you're going to remember this, or you're going to keep or get better at these things. All right, let's keep going on. Now, what about E? E. So E, we have 27. Remember, we've got a cube root, okay, or a third root. So we have 27 to the power 4/3. So you could put this in a calculator like that. Or I would say that a cube root of 27 is what? 3. So 3 to the power 4 gives you 81. 3 times 3 times 3 times 3 is 81. Okay? So that's how you deal with these kind of situations. Let's keep going. Now, let's talk about rules of exponents. Rules of exponents. The first rule is the product rule. Now, if I have a number x to the power n times another x to the power m, okay, when I have this, then this should be equal to xn plus m. It should allow me to add the exponents. So when I have the same base, x, so 2, okay, an example of this is I have 2 to the power 2 times 2 to the power 3. It's not plus, it's times. This gives me 2 to the power 5. Why? Because I add the top, the exponents. Okay? So if you look at problem 3 here, you would see that I've got x and x to the power 1/3 to the power 1/2. It's multiplying. So you add the fractions. What do you add? You add the fractions. So you have x to the power 1/3 plus 1/2, like that. So the problem now is how to add this. Put that in your calculator, that's fine. But you should be able to add this, okay? You should be able to add this. And then you get this, okay? And then you write it out as that. You know that the denominator here, the 6, is the root. So the 6th root, and then you have x to the 5th power, okay? Remember that this guy is the same. This is the same. I already discussed that previously, okay, as having the 6th root of x to the power 5 is the same thing. All right. So you try this. It says x to the power 1/2 times x to the power 1/4. So you add them, okay? You add them. Remember, it's multiplying. That's why we are adding. So you have x to the power. If you want to find the denominator 1/2 to have a denominator of 4, you have 2/2, which gives you 2/4. So I have 2/4 plus 1/4. Because I've got the same denominators, I add the top, so 3/4. Okay, 3/4. Now, what about the quotient rule? What about the quotient rule? The rule number 2. What about the quotient rule? So the rule says if I have x to the power m divided by x to the power n, then I could do x to the power m minus n. I could subtract those. Okay, this means that if I have 2 to the power 5 divided by 2 to the power 3, remember the base should be the same, 2 and 2. This gives me 2 to the power 5 minus 3, which is what? 2. 2 to the power 2. Oops. To the power 2, which is 4. Which is 4. Okay? Which is 4. Now let's look at problem 5. So this is a media example. So I'm not going to do it. Go back and then look at it. But what about if I have 3 to the power 5 divided by 3 to the power 2? So this gives me 3 to the power 5 minus 2, which gives me 3 to the power 3. What is 3 to the power 3? 3 times 3 is 9, times 3 is 27. Gives me 27. Okay? Now, this is a media example, so I'm not going to do it. Please go and then look at the video so that I could finish all that I want to do. Now, what about problem 6? I have to the power 1/2, okay, divided by x to the power, what is it, 1/3. So this gives me x to the power 1/2 minus 1/3. So again, the problem is knowing how to solve this fraction or subtract these two fractions. All right, so x to the power 1/2, if I want to change that to have a denominator of 6, I do 3 times 3, which is 3/6. What about 1/3? I have 2 times 2, which gives me 2/6. So I'm going to have x to the power 3/6 minus 2/6, which gives me x to the power 1/6. X to the power 1/6. I'm done. Okay. All right. Now, let's go back to the rules again. Now, the power rule, this rule says if I have x to the power n all to the power m, like that, the rule says, okay, when that happens, then you're going to have x n times m. You multiply the exponents. Okay, so I have x to the power n in parentheses to the power m. I multiply the exponents. So if I have something like this, 2 to the power 4 to the power 2, this gives me 2 to the power 4 times 2, which is 2 to the power what? 8. That's it. Okay, 2 to the power 8. All right. There's a media example, so I'm not going to do it. Now let's look at y to the power 2/5 and to the power 5. This equals y to the power 2/5 times 5. So this cancels that. We do 5 over 1. So we have y to the power 2 over 1, which is 2, y squared. Okay? All right. Again, these rules are very important, so you shouldn't forget them. Now, what about if I have x to the power minus n? Now, when you have a negative exponent, yes, a negative exponent, like 2 to the power negative 3, something like that. The rule says this should be equal to 1 over, you bring that down with negative, 1 over x to the power n. So, if you look at this problem here, 2 to the power negative 3, that gives me 1 over 2 to the power what? 3. 1 over, what is 2 to the power 3? 8. 2 times 2 is 4, times 2 is 8. So that gives me 1 over 8. Okay. All right. So let's go check this out. So 9 to the power 1/2, this gives me 1 over 9 to the power 1/2. Okay. That's what it gives me. And what is 9 to the power 1/2? Remember, that is the square root. Remember, the denominator of the exponent is what? The root. So I have 1 over square root of what? 9. Why? Because I have to the power 1 here. I have 1 over 3. So square root of 9 is what? It's 3. So 1 over 3. So you see that this complicated number, 9 to the power negative 1/2, just comes to 1 over 3, or 1/3. Okay. Now let's look at problem 10, because that is not a media example. So we have 2, oops, 2x to the power 1/2. Remember, the power 1/2 only affect the x, but all of them are in parentheses, and then we have an exponent of 4. So all of them inside the parentheses are affected by the 4, right? So this should give us 2 to the power what? 4. Okay, or 4 times what? 1, because 2 is 2 to the power 1, times, what about the x? X to the power 1/2 times 4, or 4 over 1. 2 goes into itself 1 time, 2 goes into itself 2 times. So we have 2 to the power 4 times x to the power 1 times 2 is 2. What is 2 to the power 4? It's 16, and then we have x squared. I'm going to do this one more time. I'm going to do it one more time, okay? I'm going to do this one more time so that you get it. Now, remember that with this, we've got 2x 1/2 to the power 4, like that. So the 4 outside affects this, it affects that, right? Okay. If that is so, then the 4, remember this is 2 over 1, 2 to the power 1, right? Any number to the power 1 is that same number itself. So 1 times 4, remember the rule, okay? If you have an exponent like this, you multiply. So 1 times 4, so we have 1 times 4 is 4, we have that. What about x to the power 1/2? We have x to the power 1/2 times 4. This is the power rule. Okay, so 2 goes into itself 1 time, goes into this 2 times. So 1 times 2 is 2. So 2 to the power 4 is 16. We've got 1 times 2 is 2, x squared. All right. Now let's talk about distance and midpoint formulas. Distance and midpoint formulas. Distance and midpoint formulas. Let's talk about that. Distance and midpoint formulas. Now, you want to find the distance between 2 points. This is the first point here. Oops. And then there's another point. So both are points. Oops. Don't worry about my drawing. So you want to find the distance between these 2 points. How do we do that? And this is the formula. Now, if you want to find the midpoint, let's say this is the middle point. Okay, this point. You want to find the midpoint. How do you do that? There is a formula for doing that. So all we are saying is that what is the distance between 2 points? How can I get the middle point or the midpoint of these 2 points? How do I do that? So the formula is that if you decide, since you have 2 points, let's say here you have -3 and 5, and then here you have +4, -2. So just like finding the slope, I could decide that this is my x1, x2, oh, x1, y1, sorry, x1, y1, because this is my x, this is my y, right? x2, y2. This is 2, this is 2. Okay, they go together. So x and y, they go together. They must go together. It doesn't matter which one becomes your x1, y1. You can see that I just chose one of them to be my ones, x1, y1, and then I chose another to be my x2, y2. I could change it, okay, for -3, 5, that point to become my x1, y1. It doesn't matter. It doesn't matter. Now, to find the distance between these 2 points, what's the rule? What's the formula? The formula says x2 minus x1 squared plus y2 minus y1 squared. That's it. And then you put all that under a square root. Okay? Don't forget the square root. You put that under a square root. And that's it, pretty much. All right, so look at this first worked example. So I have 4, 5, and then 7, 1. So if this is my x2, y2, x1, y1. So you could see from the formula that my x2 is here minus x1, which is this guy, squared, plus my y2 is 1, my y1 is what? 5. Okay, remember, you have to put the squared and then the square root. All of that is under a square root sign. And then with your calculator, you solve. Okay, with your calculator, you solve. What about the midpoint? So the midpoint, the rule says pick two x's, two of the x's, x1, x2, add them, divide by 2. It's like you're finding the average. Add them, divide by 2. And then you pick the two y's, y1, y2, add them, you divide by 2. Midpoint is very easy to calculate, right? 2 points, you have two x's, x1, x2, add them, divide by 2. y1, y2, add them, divide by 2, and that's it. That's it. That's for you. Okay. All right. So let's look at it. So problem 12 is a media example, so we are not going to do it. Now with this, let's say that my 6 here is x2 and then -6 is y2. So this becomes x1, this becomes y1. All right. So the rule says D, or first of all, let's do midpoint. The midpoint is x1, x2. So x1, x2, remember you are adding, so it doesn't matter which one starts first. So -4 plus 6 divided by 2. And then you have 4. Okay, where is the 4 from? From here. 4 plus negative 6, so plus minus 6 divided by 2. So negative 4 plus 6, that gives you 2 over 2. Negative 4 plus times minus, positive times negative is negative, so it's going to give me negative 2. That is 4 minus 6, or you put that in the calculator. So what do we have? 2 over 2 is 1. Negative 2 over 2 is negative 1. So I have that. All right, what about my distance? So my distance is going to be d equals, now I put a square root here, x2 minus x1 squared. So x2 is what? Positive 6. Minus x1 is negative 4. So minus 4 squared plus. So where is my y2? Negative 6. Okay. Minus my y1, which is positive 4 squared. So what is this giving me? Now, if you come here, you have negative, which is positive. So 6 plus 4, right? That gives a 10. So 10 squared, which is 100. Okay. 10 squared, which is 100. And then what's next? So let's keep going. I'm going to do that here. So I have 10 squared plus negative 6, negative 4, which is also negative 10 squared. Okay, negative 10 squared. And what is negative 10 squared? So negative 10 times negative 10. What is that going to give us? Negative 10 times negative 10. It's going to give a positive, right? Negative times negative will give us a positive. So we know that. So that gives us 10 squared is 100 plus 100, which gives us square root of what? 200. So you put this in the calculator, and then you know what you're going to get. Okay. So you do that, you know that you're getting 14.142. All right. So that's how you deal with these kind of problems. That's how you deal with them. All right. So I'm going to end this video here, and then the next one I'm going to continue from section 7.3. Thank you.